do. With Webb's discovery of galaxy rotations, the key lies in the type of black hole our universe might have come from. Most black holes in nature aren't static. They spin. And when they spin, they can transfer some of their momentum into the universes they create. Physicists call these rotating black holes Kerr black holes, named after mathematician Roy Kerr, who solved their equations in 1963. Such black holes don't just swallow matter. They swirl it around like a cosmic whirlpool. This rotation creates a phenomenon known as frame dragging. As the black hole spins, it literally drags space-time along with it. If our universe was born inside a rotating black hole, then the spin of that parent black hole could have imprinted a subtle, fundamental directionality onto our entire universe. That built-in rotational bias might have shaped how matter clustered and how galaxies formed. Physicist Nikodem Poplawski expanded on this idea using Einstein-Cartan theory, which adds torsion to general relativity. In his model, torsion creates a repulsive force that prevents matter from collapsing into a singularity. Instead, matter rebounds, just as black hole cosmology proposes. This framework could explain the strange imbalance that Webb has observed in galaxy rotations. If the parent black hole spins clockwise, from our perspective, then galaxies in our universe would tend to rotate clockwise as well. Of course, this doesn't mean counterclockwise galaxies can't form. We clearly observe them too. But the baseline rotation of the parent black hole might tilt the odds toward clockwise spins. That would explain the 2-to-1 ratio detected by Webb. Even more intriguingly, this effect is strongest in galaxies from the early universe. That's when the parent black hole's influence would have been most pronounced. Over time, as cosmic interactions grew more complex, the effect likely weakened. Still, science demands caution. As Carl Sagan famously said, extraordinary claims require extraordinary evidence. So if we set aside the cosmic nesting doll hypothesis, are there more conventional explanations? For Webb's discovery, one conservative answer is observational bias. Determining a galaxy's spin is notoriously difficult. It requires advanced image processing. If there's any systemic error in data collection or analysis, one direction might be overrepresented. The angle from which we view a galaxy can also affect how we perceive its rotation, and the selection of which galaxies to analyze could introduce bias as well. That said, previous studies using different telescopes and methods haven't shown such strong asymmetries. Most results have been far more balanced. Another possibility involves the cosmic web, the large-scale structure of the universe made of filaments, clusters, and vast voids. If our region of the universe is part of some massive, large-scale flow that could influence how galaxies form and how they spin. Some physicists even propose that the universe may have an inherent handedness or chirality, not because it exists inside a black hole, but due to some deeper, yet unknown physical principle. It's also worth noting that Webb's study was based on just 263 galaxies. That's groundbreaking, but still a tiny sample compared to the billions of galaxies in the cosmos. If the universe truly exists inside a black hole, it would radically reshape our understanding of its origin and structure. The universe wouldn't begin with a singularity, but rather as part of a longer cosmic cycle. Each generation of universes could have slightly different physical properties. Some might be more favorable for complex structures and life than others. Of course, black hole cosmology remains speculative. It's a frontier hypothesis, bold but unproven. It demands rigorous testing and evidence. Yet that's exactly how science progresses. Unexpected anomalies push us to propose daring ideas. Then, through careful verification, those ideas may spark revolutionary breakthroughs. From Copernicus proposing the heliocentric model to Einstein discovering that gravity bends space-time, every great leap forward began with challenging assumptions. And so, this reminds us, science is not a leisurely stroll along a straight path. It is a relentless expedition through the fog, filled with trial and error, always inching us closer to the truth.